Today we're going to talk about quadratic functions. So quadratic functions or quadratic equations are going to be equations that have an x squared in the function itself when they're written out. As we're going through this section, as we're going through our entire chapter, just a reminder that our universal set in this chapter is a set of real numbers. We're not just restricted to the integers anymore. Before we get into our quadratic equations, we want to talk a little bit about our complex numbers. Right, so our complex number system includes the roots of negative numbers. Right? In order to do this, we introduce what we call the imaginary unit. Right? The imaginary unit, which is represented by the letter I, is the number whose square is equal to 1. Right? So I squared is equal to -1, and the square root of -1 is equal to I. A complex number can be written in the form a plus bi, where a and b are real numbers. Right? If we don't have a second portion here, we actually have a real number if we just have an a. If we don't have an a, then we have a purely imaginary number if we just have a b part. Thinking about our Euler diagram that we've been discussing since the beginning of the semester. Right? We know that on the left side, our n, we start with our natural numbers, that's our smallest set. We add 0 to get our whole numbers. We add negatives to get our integers. Then we add fractions and decimals to get our rational numbers. Then we add our irrational numbers to get our real numbers. This big oval outside of our real numbers represents our complex numbers. So they include the real numbers, but we are also adding that imaginary unit, making this a larger set of numbers than just our real numbers. In example 1 down at the bottom, we're going to be asked to identify each number as real or complex. All right, so our first number, square root of 4. If we think about the square root of 4, well, the square root of 4 equals 2. Right? 2 is a natural number, it's a whole number, it's an integer, it's an irrational number, it is a real number. If we put a negative sign out front, then that represents, in this case, -2. Right? So this is also a real number. This would be considered an integer. Right? So we could get more specific. We could say that our first one is an example of our natural number. Right? This is an example of an integer. Right? We move that negative sign inside. Well, now we have a complex number. Right? So in this case, this would be a complex number because we have a negative sign inside our square root. Square root of 2, we can't simplify this or reduce this. We could change it to a decimal, but that decimal never ends or never repeats. But it is a real number because it is an irrational number. Right? So it's not a nice looking answer or number, but it is still a real number. All right, for E, here we have a little bit of calculating to do. So looking at this, square root of 3 squared is 9. 4 times 1 times 2 is 8. So the square root of 9 minus 8, the square root of 1 is 1. Right? That is a real number. Right? In F, we have the square root of 9 minus 4, because 4 times 1 is 4. We get square root of 5, which is another irrational number, which is still real. And then in this last one, we get the square root of 9 minus 4 times 2 is 8 times 2 again gives us 16. So we get the square root of -7. This would be an example of a number that is not real. It is a complex number because we have a negative sign inside our square root. So we're going to work through some problems when we get to our quadratic formula, talking about what kind of answers we can expect, whether they're real or they're complex. And we're going to see something kind of similar to what we have in E, F, and G. So just remember that negative numbers outside the square root are okay, negative numbers inside the square root are not okay, as far as whether or not they are real numbers. All right. So in this section then, we're going to focus on quadratic equations. Okay. So we've seen this definition through multiple different chapters already. Right, so a quadratic equation is a second degree equation. We have an x squared somewhere in our equation. Right, in standard form, we see ax squared plus bx plus c equals 0. So all of our terms are on one side. They're written in descending order, and we have a 0 on the other side. Quadratic equations always have either one or two solutions, depending on what we're going to see when we either try to factor or use one of our other different methods. As far as solving quadratic equations, we can solve them using factoring, as we have done before. We can solve them using the square root property, which we're going to talk about in this section, completing the square, which we are not going to choose to cover in this class, or we can use our quadratic formula, which we will also see in this section. Okay. So underneath here we have a just kind of brief overview of our methods to solve our quadratic equations. So we're going to go through these different methods step by step. So our first method that we're going to talk about is our factoring. So we're going to review some of the stuff that we talked about in section 2.6. And then we're going to talk about our square root property. Then we're going to talk about our quadratic formula. All right, so to start, we're going to start by reviewing our factoring. So all of example 2 we're going to look at, and we're going to solve these equations by factoring. All right, so the first thing I want to do here is I want to look at my equation that I have here. I have a plain x squared, so we can use what we referred to as the shortcut before. So I need two numbers that multiply to give us 39, add to give us 16. Well, that's going to be 3 and 13. So once we have these two numbers, we can rewrite our factors. So our factors are going to be x plus 3 times x plus 13 equals 0. When we're doing these, it is important to make sure that our function is equal to 0 before we start trying to factor. We're going to set each of our factors equal to 0. So either x plus 3 equals 0 or x plus 13 equals 0. Solve each of these for x. We get x equals negative 3 or x equals negative 13. Right, so when we are solving our functions by factoring, first thing we want to do is we want to make sure we are in standard form. Make sure our different pieces of our equation are in descending order. Make sure that we have a 0 on the other side of our equation. Once we have our pieces of our function in descending form, we're looking for our pair of numbers. Again, in here we were looking for a positive 39. In order to get a positive, we have two factors of the same side. So we used a positive 3 and a positive 13. We then use these factors to rewrite our equation. Then once we rewrote our equation, we set each of those factors equal to 0 and solved for x in both of those cases. For b, we're going to do the same thing. Again, we can use our shortcut. We're looking for two numbers that multiply to give us a positive 28, add to give us a negative 11. So we're going to use a negative 4 and negative 7. These will multiply to give us a positive, add to give us a negative. Right. Then we can write our two factors, x minus 4 times x minus 7 equals 0. Set each of our factors equal to 0. Add 4 to both sides to get 4. Add 7 to both sides to get 7. In the homework, since you're doing it in my math lab, you won't necessarily always be asked to write our answer in solution set, but just to kind of stay consistent with stuff we've done in previous chapters, I am going to finish both of these off with writing our answers in our solution sets. All right, let's go through some more problems using factoring. If we look at this next problem, in this next problem we do not have our equation set equal to 0 to begin with. So before we do anything, we want to move this number to the other side. So we're going to subtract 24 from both sides. Right, so we have x squared minus 2x minus 24 equals 0. Now that we have our equation in standard form, we're looking for two numbers that multiply to give us negative 24, add to give us negative 2. That's going to give us a positive 4 and a negative 6. Signs do matter. Right? We do want a positive 4 and a negative 6 to give us a negative 2 there. So then we rewrite our equation as factors. So we're going to have x plus 4 times x minus 6 equals 0. So x plus 4 equals 0, or x minus 6 equals 0. We subtract 4 from both sides, we get negative 4. We add 6 to both sides, we get positive 6. And in our solution set, we can put our negative 4 and our positive 6. D. Do you notice that we have something that we referred to as a difference of squares? So looking at this one, thinking back to section 2.6, we referred to these problems as a difference of squares because we have two numbers that are perfect squares separated by a minus sign. When we factor a difference of squares, we end up with identical factors only with opposite signs in the middle. So in order to get x squared, we take x times x. In order to get a negative 49, we take a positive 7 times negative 7. If we were to multiply these out, our middle numbers cancel, right, which is why we only have two pieces or a binomial set equal to 0. So we can set each of our individual factors equal to 0. Subtract 7 from both sides to get negative 7. Add 7 to both sides to get positive 7. And our solution set is going to be negative 7 and positive 7. Right. Looking at E. So like we did in example C up above, the first thing we want to do is we want to move over our term that is not in the correct place. Right. So we're going to subtract 9x from both sides. So we get 4x squared minus 9x minus 9 equals 0. Right, here, since we have a coefficient on our x squared, we have to multiply. 4 times 9 is going to give us negative 36. So we need two numbers that multiply to give us a negative 36, add to give us a negative 9. We're going to use a positive 3 and a negative 12. Now when we write this problem, we need to remember and we need to think about, again, going back to section 2.6, we can't just jump right to our factors for our answers. So I'm doing this problem using grouping. You can do this problem using another method if you so choose. Right, but looking at this, we're going to go up and we're going to rewrite our original problem. And I'm going to rewrite our original problem as 4x squared, because we keep that 4x squared. Instead of writing minus 9x, I'm going to write plus 3x minus 12x, using that pair of numbers that we had. Minus 9 equals 0. Right, then I'm going to group these into pairs. So looking at my first pair, I want to take out my GCF. Well, the only thing that these first two terms have in common is an x. So we're going to divide out an x. 4x squared divided by x gives us 4x. 3x divided by x gives us 3. In our second pair of terms, we're going to divide a number out of both of these. We cannot remove our variable for a GCF because our 9 does not have a variable attached. Both of these are negative, so we're going to divide both of these by negative 3. Negative 12x divided by negative 3 is going to give us positive 4x. Negative 9 divided by negative 3 is going to give us positive 3. So we have removed our GCF from each pair. If we look at what we have here, right, we have a 4x plus 3 that is in common, so that's going to be one of our factors. And then we have an x minus 3 for our other factor. Right, so we're going to set both of these factors equal to 0. I'm going to move up here just so I have a little more room. 4x plus 3 equals 0. Or x minus 3 equals 0. We're going to subtract 3 from both sides and then divide by 4. We get x equals negative 3/4. Add 3 to both sides on this one. X equals positive 3. Unlike in the last two chapters, we can use fractions or decimals as answers. So we're going to include both our negative 3/4 and our 3 in our solution set. So again, if your coefficient of x squared is not just a plain 1, you can choose to do the trial and error method. I chose to work through it using the grouping method. but then we work through and we still get 2 solutions in the end. F is going to be very similar. So here we don't have to move anything over. We are in standard form. So we're going to multiply. 12 times 5 gives us a positive 60. That means our 2 factors have to have the same sign. In order to get a negative 19 for a sum, both of these need to be both of these need to be negative in order to get a negative. But if both of these are the same sign, that will give us a positive product. So we're going to use negative 4 and negative 15. Those will add to give us a negative 19 and multiply to give us a positive 60. All right, so now we're going to rewrite our problem. 12x squared minus 4x minus 15x plus 5 equals 0. We're going to remove our GCF from our first pair. These have a 4x in common. So 12x squared divided by 4x gives us 3x. Negative 4x divided by 4x is going to give us negative 1. Our other pair, we're going to remove a 5. In order to make our signs match up, we're going to make sure that we use a negative 5. That generally is the case if we see a negative right here in the middle. So negative 15x divided by negative 5 is going to give us positive 3x. Positive 5 divided by negative 5 is going to give us a negative 1. And then we still have our equals 0. Right, so our first factor here is 3x minus 1, because that's what are shared in common in our parentheses. And then our leftover pieces are 4x minus 5. So we're going to take this 3x minus 1 and set it equal to 0. And our 4x minus 5 and set it equal to 0. Add 1 to both sides to get 3x equals 1. Divide by 3. X equals 1/3. Add 5 to both sides. 4x equals 5. Divide by 4. X equals 5/4. So in our solution set we get 2 fractions. Fractions, decimals, improper fractions, mixed numbers, however you want to write your answer are perfectly acceptable, right? But all of those are included as solutions. All right, so one way that we can solve our quadratic equations is going to be factoring. Right. The next 2 different ways are actually going to be the 2 new ways for this section. So I'm going to go ahead and stop this video here, and then we will continue with example 3 in the next portion of this section.